Okay, so I figured this would be easier. So I've taken the central board out of this Proxmark so you can see the actual HF antenna. But basically, imagine this is bigger, right? And what you're going to get is you're going to get these tubes, right, running around the entire thing like this. And the the reason that this matters is that your electron flow is in a direction, which means that the tube flux is going to be going in a direction. But as it turns the corner, it's going to be going in the opposite direction, right? So this direction and this direction, if they meet, right, in the middle, they kind of cancel each other out. Same thing for this, right? So what you need is this kind of donut shape with a hole in the middle, so that when you present this, right? So when you present your antenna, let's just imagine it's a card, so it has a similar shape. You want those lines of flux to line up at the same way around, so it's pushing the electrons around the circle, right? So if you have a very small tag in the center, and you have a high voltage, so these tubes are really getting big, right? And it's a tube, so when you talk about a plane, when you say how high it gets, it's just a matter of what the diameter of those magnetic flux tubes are. So you're going to get the same below as above, as to the side as to this side. So when you cross those two in the center, they cancel each other out. So if you have a tiny little fob in the middle here, you're in the cancellation zone, right? There's like no electrical potential being generated, because everything's kind of pushing against and canceling each other out in that area. But as the z-axis increases, those tubes bend away from each other, and then you can catch the edges of those tubes without the cancellation with your tag antenna. So really, that's just what it's all about. Is you can, if you filled this in, right, then you would just have a ton of cancellation happening in here, and your tiny little fob wouldn't really get much performance either. Now, when we start talking about X series and cylindrical coils, that's a whole different ball of wax, and how they interact with those tubes is totally different. But when you're talking about flat plane stuff, that's what you need. You need something that essentially, if you had two exact matching antennas and a power level that wasn't insane, then you could get to the top of those tubes, right, at the maximum distance away, if it was aligned perfectly. So this kind of explains, when it comes to payment terminals, when you have to do certifications for your device, they do dead center. They do dead center at 4 centimeters. They do 2 centimeters and 2 centimeters offset, 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 offset. So you have to be able to get a read in all those areas of the terminal. And so there's all this interplay that has to happen. And of course, you're only designing a tag, you're not designing the terminal. So they have like 20 different terminals. You have to achieve that with all those different terminals. And you only have control over the shape and size of your payment device. So it's very difficult to tango when you don't know who your partner is going to be. But anyway, so I hope that makes a little bit more sense as to how this all works, and why a high power large antenna has problems down at the bottom. Either it's in the cancellation zone, or the tubes aren't making it far enough in and to catch the edges. But generally speaking, it's usually because of cancellation.